This is the recording of Chapter 2, Part 1. In this chapter, we're going to talk about describing motion. So, imagine you're driving home from school, okay? And let's say you drive in a straight line. So there's different ways you could describe this trip. You could tell me the distance that you went. You could tell me the route that you took. You might say, I turned left at the pink house, and so forth. But in physics, we need a more precise description of our motion. We do realize that your position continually changes as you drive, and we know that it takes time for you to make the trip. So these two fundamental notions, space and time, are basically at the core of our concept of motion. Furthermore, different positions along the trip can be matched with different times. So one relationship we have with space and time is the simple question, how fast were you going? So we can look at that question in two ways. We can look at answering it in terms of the total trip, or we can look at answering it the moment-by-moment details of your trip. So for your total trip, we're going to use what we call average speed. Average speed, we define it as the total distance traveled divided by the time it took to cover the distance. So our formula for average speed is S equals D over T. The line over S just simply means average. And as we go through this semester, you will see the line over other variables in other formulas. Now, our units for speed is typically going to be meters per second or kilometers per hour. Now, how can we represent motion? There's different ways we can represent motion. This top picture is what we call a motion diagram. So notice on the x-axis, it is distance, okay? And we start off at 0 minutes. Okay? Now, we could also represent it as shown in the bottom as a table, which will show us the minutes, our time, and the corresponding position. Another way we could represent motion is simply by having a graph of x versus t. So on our x-axis would be time, and on our y-axis is our distance. And notice in this instance, we've graphed our motion. We also have on the left another table of our diagram. So whenever you're asked to do a graph of A versus B, it simply means that the first variable, which in this case is A, is on the vertical axis, and the second variable, which in this case is B, is on the horizontal axis. So what we're looking for, or what we're seeing in this particular graph, is called a position graph. It is position versus time. And our curve that we see is our object's position as a function of time. So an example would be you live 40 miles from school and it takes you 2 hours to drive. So using our formula for average speed, which is distance over time, we have our 40 miles over our 2 hours. So we're actually, average speed is 20 miles per hour. Now, a lot of times you will see miles per hour abbreviated as mph. It's very important that you put your units with your answer, because if you just told me my average speed was 20, I have no idea what units you're talking about. Okay, now keep in mind when you're looking for average speed, you're disregarding the specific details of your trip. Okay, let's do a couple sample problems where we're going to calculate the average speed. And also, if you notice on Canvas, under our Exam 2 module, I have included the formula sheets for Chapter 2 as well as Chapter 3. On these formula sheets, I do allow you to write the different ways you could solve that formula, as you see in the example I give you on average speed. So in this one, whenever you're tackling a word problem, you want to make a list of what you're given. So what is the average speed? So we're looking for average speed. So we're going to put average speed equals a question mark. We're given that it flies 3,000 miles, so we know that's our distance. So we write 3,000 miles, and it does so in a time of 6 hours. So we can look on our formula sheet and we see that average speed is simply distance over time. So your average speed is going to be your distance, which is 3,000 miles, over your time, which is 6 hours. And that is going to be 500 miles per hour. And remember, you can write that as 500 mph. Now, if we wanted to give our answer in correct significant figures, our smallest significant figure is 1 digit. So then we would write it as 5 times 10 to the second miles per hour if you were asked to give your answer in correct significant figures. Next sample problem is we have a race car that travels 500 miles. So we know our distance is 500 miles. And it does so in a time of 3.67 hours. And you're asked to find average speed. So again, our average speed is distance over time. Our distance is 500 miles. Our time is 3.67 hours, and we simplify that to 136 miles per hour. Now in this one, if you were asked to give the answer in correct significant figures, you would be looking at 1 digit because the 500 doesn't have a decimal place. So in order to put this in correct significant figures, you would have 1 times 10 to the second, and you could put mph. Okay, so if we know the average speed, we can also take that formula and we can solve it for the other variables. So we could find the time needed for a trip. So what we do is I have the formula shown for solving for time, but let's go through how we got that. So if we had average speed is distance over time, and we're looking for time, so we can multiply both sides by t, and then we cancel our t, and then we get t times average speed equals d, and then because we're looking for time, we're going to divide both sides by t. My t's are going to cancel. Oops, and I didn't want to cancel my t's. I made this mistake. So I'm going to go back and I'm going to erase this and start again. So I have speed equals distance over time. I'm going to multiply both sides by t. T's cancel. And now I want to divide by average speed. So I'm going to divide by average speed. Average speed cancels. So what I'm left with is time equals distance over average speed. Okay? So I fill in the numbers I'm given. My distance I'm given in the problem was 60 miles. My average speed is 50 miles per hour, and therefore my answer is going to come to 1.2 hours. And now there's one other variable in that formula, and that is distance. So when I rearrange it for distance, I get distance equals average speed times time. So now in my problem, I'm given a speed of 50 miles per hour, and I'm given a time of 8 hours, and I'm asked to find my distance. So my distance is going to be 50 miles per hour times 8 hours, which will give me an answer of 400 miles. Okay, let's do a couple practices. So in this problem, we're going to write down what we're given. So we have a car traveling at a rate of 55 miles per hour. So your average speed is 55 miles per hour. And it does so in a time of 6 hours. And you're asked for how many miles did it go. So you're asked for the distance. Now, I have average speed is distance over time. So I'll multiply both sides by t, cancel my t. So then I have t times average speed equals my distance. So distance is going to be 55 miles per hour. And I'm writing it like this so you can see how the units cancel. Times 6 hours. So my hours cancel. I'm left with units of miles, which is a unit of distance. And you get 330 miles. Which again, if you're asked to put in scientific notation because your time was 1 digit, then you need your answer in 1 digit. So you put it in scientific notation, and that would be 3 times 10 to the second miles would equal your distance. Okay, in this next one, we're looking for how long will it take a car traveling at 60 miles per hour. So we know our 60 miles per hour is our average speed. We're told a distance of 480 miles, and we're asked to find the time. So once again, we have average speed is distance over time. We're going to multiply both sides by t. T's cancel on the right. So we have time times average speed equals distance. And we're going to divide both sides by average speed, which is going to give us our formula as time equals distance over average speed. Now, you have these formulas on your formula sheet. I'm just showing you to give you some more practice on rearranging the formulas. And remember, you can have your formula sheet on the exam to use with you. You just will have to show it when it asks you for notes. Those are the only notes you are allowed to have, your formula sheet and your conversion sheet. So our time is going to be our distance, which is 480 miles, and it's divided by 60 miles per hour. So miles cancel. This hours come up to the top. So our time is going to equal 8 hours. Okay, we also have what's known as instantaneous speed. So when you're looking at what we just spoke about, average speed, it's limited, okay? Because when you tell me, my average speed to get to class was 55 miles per hour, It doesn't tell me all the details of your trip. It doesn't tell me where you were stopped, where you made a turn. It doesn't tell me how fast you were going when you passed the street. So we want to know a little more than simply average speed. And that would be what we call instantaneous speed. It's how fast you were going at a specific time, at a specific point. Okay? The best way to tell your instantaneous speed is what's on your speedometer. If school zones are in effect, school's just beginning. So when that policeman shoots that radar gun at you, they are looking at your instantaneous speed. That instant that that gun records your speed determines whether or not you were speeding. Now, when you look at average speed and instantaneous speed, they are similar. They only differ in the size of the time interval. Okay, so if I want to know how fast you're going at a given instant, we have to have a very small time interval. So when you speak of instantaneous speed, it's basically equal to the average speed over a time interval that's very, very small. Now, question that always comes up, how small is small? Well, how small is small? You need a time interval that's small enough that your average speed doesn't change very much. Okay, so that's how small can be. Okay, this ends part 1 of chapter 2's recorded lecture.